Picking back up with our Algebra 2 practice test, looking at the second page, lots of simplifying radicals and exponents like number 9, 8 to the negative 2/3. One way you could do this, realize that negative exponents mean take a reciprocal. Just like we did on the front page, however, you could notice that this fractional exponent is really a radical. This would be the cube root of 8 and then squaring it. Now the cube root of 8, what you can do very fast is just hit math and come down here to number 4 and quickly see that the cube root of 8 is actually a 2, and wonderful to get that. You can say this is 1 over, that's really 2 to the second. 2 to the second is, in fact, 1/4. That's going to be your final answer. But I do want to point out what you could have done also, at least for this problem, is you could have earlier on typed in 8 raised up to the negative 2 divided by 3. You'd get 0.25, but when you hit math, and if you'd say please express that as a fraction for number 1, you'd also get 1/4. So this is a problem that you could, in theory, just type straight into the calculator and do it quickly. I definitely don't want students to lose sight of the connection, though, between fractional powers and radicals. For number 10, we really need to break this down. 54, let's look for a division tree. We could say, well, the first prime number that we have is 2. 54 divided by 2 is 27. Now a 2 won't divide into 27, but a 3, which is our next prime number, would. 27 divided by 3 is 9. And finally, we can divide out a 3 again. 9 divided by 3 is 3. What we're going to see is this right here, 54, is 2 times 3 times 3 times 3. Now, of course, there's more to this problem. There's x to the 5th. That's 5 x's multiplied all together. You can see I literally wrote out a product of 5 x's. With y to the 4th, that would be 4 y's. And you can see I've literally written that out as well. But super important for us to realize this index, this cube root, is really telling us that if we want to take something out of the radical, we need to have 3 of the same item. So we're going to look for groups of 3. And every time I have 3 of the same factor, 3 of the same number or variable, I'm going to circle that. Now, what we've been saying is whatever you circle, you may take one of those items out. So I'm going to take out a 3, ignore the rest. You don't have any more 3's in that circled in the radical. Take out an x, also take out a y. So just take one of those circled items out. Then you ask yourself, well, what's left? What's still inside that radical? Well, we have a 2. We have x times x, which is really x squared. We also have a single y. That will be our final answer. Please realize the radical that I'm writing, I'm being very, very clear that it is still a cube root. It's still a third root. Last one on the video, number 11. We're going to have to break down 18 and 15 with a division tree. So with 18, we can say, well, check 2. 18 divided by 2 is 9. 2 doesn't divide into 9, but a 3 does. 9 divided by 3 is 3. So this 18 is really 2 times 3 times 3. Let's do the same thing with 15. 2 doesn't divide into 15, but a 3 does. 15 divided by 3 is 5. 5 is a prime number. We really have our prime factorization. 18 then is going to be written as the cube root of 2 times 3 times 3. 15, well, we can write that as 3 times 5. And then I'm going to join these two radicals together. I'll have 2 times 3 times 3. I'm going to put another 3 and a 5 in. But just like we were doing earlier, I'm looking for 3 of the same item. And I do have 3 3s. So out comes a 3. What's left? Well, you've got a 2 and a 5. 2 times 5 actually works out to a 10. Final answer, 3 times the cube root of 10.